and welcome to Scale Factors and Similar Shapes with Cubic Education. In this lecture, you'll know what a similar shape is and use a scale factor to calculate missing lengths, areas and volumes. Okay? And you'll also work with similarity with nested diagrams. You'll prove two triangles are similar and calculate scale factors. Okay? It sounds like quite a lot, so let's get started. So let's start by calculating scale factors. A scale factor is the amount the shapes are enlarged by. Every side of the shape is enlarged by the same scale factor. Let's take a look at these two shapes. Shape A and B are mathematically similar. We've got one shape A with the bottom length being 5 centimetres and shape B with the bottom length of 20 centimetres. We know that 5 times something is 20. That something is called a scale factor. Let x be the scale factor. We know that 5 times something, meaning 5 times x, equals 20. So if we divide that by 5, we know that x equals 4. So our scale factor is 4. Shape A and B here are also mathematically similar. We also know that 4 times something makes 9. So let's let x be the scale factor. 4 times something, or 4 times x, equals 9. So if we divide by 4, we know that x equals 9 divided by 4. So we could say that's 2.25 if we wanted to, or we can leave it as a fraction. So the scale factor is 9 over 4. By forming an equation, find the scale factor of enlargement for the following similar shapes. You've got 4 questions. Why don't you pause the video and have a go? Okay, if you've paused the video, we can see that shapes A and B in each question are mathematically similar. So let's look at the first one. 8 times something makes 16. So 8x equals 16. 16 divided by 8 is 2. So x must be 2. So well done if you got that right. So then the next one, 3 times something is 5. So 3 times x is 5. If we divide by 3, x equals 5 over 3. Okay, so you can just leave it like that. This one here, 6 times something equals 9. So 6x equals 9. Divide by 6. So x equals 9 over 6, or we can cancel it down to 3 over 2. We could also write that down as 1.5 because 3 divided by 2 is 1.5. So we can either say that x is 3 over 2 or 1.5. Sometimes it's just easier to leave it as a fraction. It's still correct. And then on the last one, 4 times something equals 7, or, okay, so in this case, all of these ones were smaller first, whereas in this one we've got one that's A is bigger than B. So we could instead say 4 times something equals 7 and do the same way, or you could do 7 divided by something makes 4. Okay, so if the scale factor is 7 times something equals 4 instead, it's obviously going to be work its way around into a division. So that means that x must be 4 divided by 7 because we need to get that x on its own. Okay, and you can just leave it like that. Okay, so now then, let's have a look at seeing if we can calculate a length after we've found the scale factor. So example 1, shape A and B are mathematically similar. Calculate the missing length. So the first thing we need to do is use 2 of the sides that we do know in order to work out the scale factor. So 5 times something must make 8, okay, because they're both similar lengths. So if we let the scale factor be x again, 5 times something equals 8. So 5x equals 8, which means that the scale factor is x equals 8 over 5. So the scale factor is 8 over 5. That means that we know that 8 times something will give us this, and that something is 8 over 5. So if we do 5 times 8 over 5, giving us 8, we can do 8 times 8 over 5 to give us this length. 8 times 8 over 5 is 64 over 5. So when we multiply like this, we just do 8 times 8, giving us 64, over whatever number's here, which is 5. Okay, so we could write that as 12 and 4 over 5 as well. And if you can't remember how to change top-heavy fractions into mixed numbers, then please go back and watch the video on that. You can also write that as a decimal as 12.8 centimetres. Okay, let's have a go at this one then. Shape A and B are mathematically similar. Calculate the missing length. So first of all, we look at the 2 sides that we do know, and we know that 4 times something gives us 9. So 4x must equal 9. if we divide by 4, we know that x is 9 over 4. So our scale factor is 9 over 4. That means that 4 times 9 over 4 gives us 9. So we can do 6 times 9 over 4 to find the missing length. 6 times 9 over 4 is 6 times 9, which is 54 over 4. We could write that as 27 over 2 or 13.5. Okay, so last example then. So here we're going to have to divide by a scale factor instead of multiplying, because this time we don't know the size of the smaller one. So again, we need to work out the size that we do know. So here we've got 3 and 8. So if we know that 3 times something gives us 8, so 3x equals 8, we divide by 3, giving us a scale factor of 8 over 3. So to get from 3, we do times by 8 over 3 to give us 8. But here, instead of timesing, we don't know it, so we have to go backwards and divide. So we have to do 7 divided by 8 over 3 to give us this smaller number. So if we do 7 divided by 8 over 3, if you haven't watched the video on dividing fractions, you must go back and watch that. But basically, all we do is flip this fraction over and do 7 times 3, which is 21, and then 8 would have been on the bottom. And we can write that as 2.625 centimetres. Okay, so why don't you pause the video and have a go at these questions and press play for the answers. Okay, if you've pressed pause, A and B are mathematically similar, calculate the missing lengths. So for the first one, we know that 6x equals 10. Divide that by 6, giving us 10 over 6 or 5 over 3. So our scale factor is 5 over 3. So if we do 5 times 5 over 3, giving us 25 over 3 or 8 1/3 centimetres. Okay. So for this second one here, we know that 4 and 10 are the same sides. So 4x equals 10. Divide that by 4, gives us 10 over 4, which can cancel down to 5 over 2, and 5 divided by 2 is 2.5. So our scale factor is 2.5, so I can do 3 times 2.5 to give us the size of the length on the shape B. So 3 times 5 over 2, or 3 times 2.5, leaves us with 7.5 centimetres. Okay, on this next one now, we're going to have to work out our scale factor and then divide by the looks of it. Yeah, maybe, let's see. So we know that to get from 3 to 2, okay, it's 3 times something makes 2, so 3x equals 2. If 3x equals 2, we divide by, 3.5x rather, we divide by 3.5, so 2 divided by 3.5, to leave x on its own, and we can cancel that down to 4 over 7. Now I know that looks odd saying cancelling it down, but I don't want a decimal on the bottom, so I times by 2 to give us 7 on the bottom and 4 on the top, leaving us with a really nice fraction to work with. Now what we need to do is find this length here, so we need to do 5.2 times by 4 over 7 to give us this length, giving us 2.97 centimetres, okay, to 2 decimal places. Okay, on this third one, we have this side that we do know, this side we don't. So let's look at these two sides. Okay, we know that 9.1x equals 6.2. Divide by 9.1 gives us 6.2 over 9.1. So our scale factor now, again, times by 10 here to give us a nice fraction. We don't want any decimals, so easily times them both by 10 to give us 62 over 91. So our scale factor is 62 over 91, so we can do 7.8 times 62 over 91, which equals 186 over 35, okay, or 5.31 centimetres. Now, both of these will come up on a calculator paper, so don't panic, you can just use the numbers. So if you've got this here and you divide by 9.1 and you get a decimal, use that decimal answer, don't worry about the fractions. Okay, on this last one here we have 10x equals 15.5. So divide by 10 and that gives us x is 1.55. So our scale factor is 1.55. 2 times 1.55 gives us 3.1 centimetres for the last one. So well done if you got all those right, they're quite tricky. So if x is the scale factor for length, then the area scale factor would be x squared. So, using scale factors to calculate area, example 1, shape A and B are mathematically similar, calculate the area of shape B. Well, the first thing we need to do is work out the actual scale factor. So I know that 8x equals 10 because 8 times something equals 10. If I divide by 8, it tells me that my scale factor is 10 over 8, which I can cancel down to 5 over 4. So I now know that my scale factor is 5 over 4. I know that my area scale factor is 5 over 4 squared because it's an area, so we square it. So we just square both numbers, 25 over 16. And now I know the area of this shape, which means to get to the area of that shape, I must times by 25 over 16. So 75.2 times 25 over 16, which again would come up on a calculator paper, gives you 117.5 centimetres squared. Okay, so let's have a look at this example. We have two shapes, calculate the area of shape B. So to get from 6 to 14 at the bottom there, we need to times by something. So 6x equals 14. So if we divide by 6, x, our scale factor, would be 14 over 6 or 7 over 3. So if that is correct, then our x squared value must be 49 over 9. So here is our area. To get to the area of B, we must times by 49 over 9. So 31.5 times 49 over 9 is 171.5 centimetres squared. Okay, so why don't you pause the video and have a go at finding the areas of these shapes. Okay, if you pause the video and had a go. So the first one, we need to get from 5 to 8 to find our scale factor. 5x equals 8, which means x equals 8 over 5. X squared is 64 over 25 because it's our area. So we just square that number, and then we times that by the area of this shape, giving us 119.04 centimetres squared. Number 2, 6x equals 18, giving us x equals 3, and x squared would then be 9. 9 times 8.8 is 79.2 centimetres squared. 2.5x equals 1.5, which means x would equal 3 over 5. So we can divide by 2.5 first, and then we just times by 2 to give us a nice fraction. 3 over 5 squared is 9 over 25. 9 over 25 times 22.4 gives us an area of 8.064 centimetres squared. On the fourth one, we have 8x equals 3.5. So 3.5 divided by 8, and we have doubled it here to give us 7 over 16 because we don't want a decimal. So x is 7 over 16, so x squared must be 49 over 256, and we times that by 46.5 to give us an area of 8.90 centimetres squared, 2 decimal places. And finally, 4.25x equals 15.3. 15.3 divided by 4.25 gives us 3.6. 3.6 squared gives us 12.96, and we just times that by the area of 46.5, giving us 602.64 centimetres squared to 2 decimal places. So well done if you got all those right. Some of those were very tricky, so well done again. Finally then, let's have a look. So length scale factor is x, area scale factor is x squared, which means the volume scale factor must be x cubed. So let's just quickly go through a few volume questions and we're done. So using scale factors to calculate volume, shape A and B are mathematically similar, calculate the volume of shape B. And all that you do here is exactly the same thing as you did before, and we need to know that to get from 5 to 12, we need to find the scale factor. So 5x equals 12, which means x must equal 12 over 5, okay? So we now need to cube that, so 12 cubed is 1,728, and 5 cubed is 125. So we are doing volume, hence we are cubing it this time. So then we just times that by our volume of our smaller shape, which gives us 2,903.04 centimetres cubed. Now this fraction here, if you put that in your calculator and it gave you a decimal, then please use it instead of the fraction if this is confusing you. It will just give you a number instead. Okay, and that's the volume of that shape. Now, the beauty of this is, when you know the volume of one cylinder, we can find the volume of another one without having to use pi or anything like that. So let's find the scale factor for this one. We know that 12x equals 9, which means x must equal 9 over 12, which we can cancel down to 3 over 4. 3 over 4 cubed is 27 over 64. 210 times 27 over 64 is 88.59 centimetres cubed to 2 decimal places. Okay, so why don't you pause the video and have a quick go at these questions and press play for the answers. Okay, if you pause the video and had a go, let's have a look. So for this first one, we've got 5x equals 6, so x equals 6 over 5. 6 over 5 cubed is 216 over 125. We can times that by 38, giving us an answer of 65.664 centimetres cubed. For the second question, we've got to get from 3 to 5 to find our scale factor. 3x equals 5, so then x must equal 5 over 3. 5 over 3 cubed is 125 over 27. And we need to do 82 now divided by that amount. The reason for that is we are going from this larger shape back to the smaller shape. Okay, so if we divide that, it gives us 17.712 centimetres cubed. On the third one, we need to get from 8 to 3, so we know that 8x equals 3, which means x equals 3 over 8. 3 over 8 cubed is 27 over 512, and 50 times 27 over 512 is 2.64 centimetres cubed. And finally, we have got to get from 3.5 to 5.5, so 3.5x equals 5.5, and x must equal 5.5 over 3.5. We can then cube that, giving us 1,331 over 343, and then we times that by, divide that by 64, so we do 64 divided by this amount to get back to the smaller shape. To do that, it gives us 16.49 centimetres cubed to 2 decimal places. Okay, so let's have a quick look at some nested diagrams. So these can be a little bit tricky, so make sure you take some detailed notes. ABC is a triangle, BC is parallel to DE. Find the length of BC. So first of all, draw out the two separate diagrams. Okay, so we have the large triangle and the small triangle. We know that this has a measurement of 3, and we don't know the bottom length. We also know that this is 8 because 5 add 3 is 8, and we know that that's 12. So we can work out using a scale factor the different sizes of the lengths. So to get from 3 to 8, because they're the two lengths that we do know, we do 3x equals 8, which means x must be 8 over 3. Okay, and then if we do 12 divided by 8 over 3, because we're going back to our smaller shape, it gives us 4.5 centimetres. Okay, let's have a look at this example. This is a little bit different. So I need to find the length of CD and the length of AC. So CD is this length here, and AC is this length here. So first of all, we need to look at this diagram as if it's kind of like a pivot. So actually it's that way round that the sides match. So it's the opposite sides that are matching. Okay, so this 6 doesn't go with this 7. Alright, it goes with this one. Okay, this 10 and 12 do go together. So we have our two separate triangles, and we've got our measurements here. So we've just drawn them out again so that we know which measurements are which. We know then to find CD, we can find a scale factor using 10x equals 12. So 12 divided by 10 is 1.2, or 6 over 5. Okay. So if we do 6 times 6 over 5, because we've found our scale factor, and we need to find this length. So our scale factor is 6 over 5, so we can do 6 times 6 over 5, giving us 7.2. So this one would be 7.2. And then to find the length of AC, well, AC is this length here. Well, we know that this is 7, so we can divide this time. 7 divided by 6.5 is 5.83 centimetres to 2 decimal places. So why don't you pause the video and have a go at these ones and see how you get on. Okay, so if you pause the video, for the first one we have our two smaller triangles. Our scale factor is 4x equals 9, which means x must be 9 over 4. So if we know our scale factor, we can then find side AB. So we can do 18 divided by 9 over 4 to give us 8, because we're going from the larger triangle to the smaller triangle. So AB must equal 8 centimetres. To find B, which is CE, we will do 10 times 9 over 4, giving us 22.5 centimetres. For the next one, we have these two triangles here. So let x equal the scale factor, so 6.1x equals 7.3, because we know that this side matches this side. So x must be 7.3 over 6.1, which I've times by 10 to give us a better fraction. If that's our scale factor, we can then do 8.5 times 73 over 61 to give us this side, giving us 10.17 centimetres to 2 decimal places. Okay. For this one down here, these are our two smaller triangles. These ones I find more difficult than these ones because I find it hard to twist it around and realise which numbers are which, whereas these ones are a bit better. So here we have our two triangles. We need to find our scale factor. So we can say that 4x equals 10 because these match. So x must be 10 over 4 or 5 over 2 or 2.5. We can then do 10.5 divided by 5.2 to give us this length, okay, which is 4.2 centimetres. And that's it for that one. And finally, find AB. So these are our two triangles. Again, a little bit tricky with the y's. We have AB equals y, which means AD must equal y plus 4. Now let's do our scale factor first. So we know that 6 and 11 match. So 6x equals 11, which means x equals 11 over 6. To find AB, which is this one here, we can do y times 11 over 6, okay, because y times this value will give us this, and it's also equal to y plus 4. If we have this equation here, we can then rearrange it to find y. So 5 over 6 y equals 4 on its own because I've subtracted a y. Then we can multiply by 5 over 6, divide by 5 over 6 to give us y equals 10 over 3. If we know that y equals 10 over 3, we can times that by 3, giving us y equals 10 over 3, giving us this value here, 3.33. We would then just add 4 onto it to find this value here. That one was very tricky, so don't worry if you struggled on it. It's more of a higher paper. Okay, so you covered a lot in that lesson. You should know now what a similar shape is, and you should be able to calculate scale factors, use scale factors, to calculate missing lengths, areas and volumes. I'm sure those bits were the ones that you did really well, in which case I think you'll be absolutely fine for your exam. If you are thinking of doing a higher paper, then these ones are the ones that you really need to concentrate on. So I'm hoping that you understood working with similarity with nested diagrams and proving that two triangles are similar. Okay, so well done. Thank you so much for using Cubit Education, and I'll see you next time.